about USB Armory. Welcome.
Thank you. Can you hear me?
So this is just for the video. This is for people to hear. So this I will that one.
Hi. So let's get started. So today's talk is basically going to be about weaponizing the USB Armory. Before I continue, how many of you have worked with the USB Armory before? Nice. That's more than I expected. But this is basically going to be about how to use it for offensive exploitation or in pen tests. So let's get started. So I'm currently a security analyst in Netherlands. I work for a company called Riskio. But I've just joined it like 3 months back. I've been working in embedded security for the past 4 to 5 years. I mainly concentrate on embedded security as such, finding debug ports, dumping flash memory and such. But sometimes I also work on radio security, finding vulnerabilities in radio emissions and other things that work remotely. That's my Twitter handle. If you need to get in touch with me, you can use that. That's enough about me. So, what exactly is the USB Armory? It's basically a handheld device. So that's a device. Sorry, it should have been in the previous slide. But yeah, it's basically a USB form factor device that allows you to emulate USB connections and do a lot more on a small form factor. So the main reason I bought it, and I'm sure many other people bought it, is because till the USB Armory came into play, if you wanted a small Linux device, your most probable option was to get Raspberry Pi. But with the USB Armory, you can have something that you can plug directly into your computer and play around with the USB subsystem of the Linux kernel. So we will actually be focusing on the USB subsystem, but we'll also talk a bit about how to utilize the USB Armory completely as an embedded device. So it's got a few GPIOs that we can leverage later. How many of you have worked with embedded devices before? Raspberry Pis, Arduinos? Great. Embedded security? Great. So, yeah, so ARM Trust Zone is basically one of the features that the USB Armory supports. It's basically a security feature. We will not be talking about it much. But yes. The other thing to keep in mind is it's not that easy to get hold of, because I think the crowd supply page is still up, and I'm pretty sure that maybe 5,000 people around the world have it, because at least going by the sales that I see on crowd supply, not many people have this, unlike the Raspberry Pi or the Teensy. It's created by a company called InversePath, Andrea Bersani. You might know him from his other projects on embedded security or embedded devices. But yeah, that's about it for the USB Armory. The next thing we're going to talk about is HID attacks and how it relates to us today. So HID attacks is basically imagining that a person is there right next to your system and plugging in his keyboard and mouse and doing whatever he wants. It sounds simple, but using just this, you can bypass a lot of security measures implemented in the companies. Take, for example, the fact that you actually might have endpoint security systems that might block USB storage devices. But are you sure it also blocks devices that are composite, as in devices that are both mass storage and Ethernet, or mass storage and HID? Even if they do, how do they actually use, or how do they implement it? And HID attacks are something that is often overlooked because obviously if you're not working on a headless system, you would need a keyboard and a mouse to operate the system. And this attack basically uses that loophole to get in. These are not new attacks. This is not something new. It's been around for at least 5 years now, and probably more. But in this talk, we'll just see how we can use the USB Armory for such attacks. As far as I know, there have not been any real-world attacks using HID devices, but at least according to me, we'll probably be seeing them sometime soon. It's also a low-cost attack vector. You don't need to burn 0 days and attack the network, or you don't need to find your way inside the building that you're pen testing or the building that you're trying to attack. Just dropping a few USB sticks, which act as HID devices, which you have programmed, is quite enough. And currently, there are both commercial and open source implementations that allow you to run various payloads against devices, depending on the operating system, what type of payload you want, do you want network or not. A few examples is Nishan, written by Nikhil Mittal, who was a speaker here. It is also used extensively for HID attacks. You also might have heard of the Rubber Ducky, which is a commercial implementation which has its own Ducky script. So, at least for me, I started with HID attacks back when the Teensy was popular. So Teensy is a microcontroller. It's also ARM architecture. But the thing about Teensy is it allowed you to play with the USB protocol a lot. If you wanted to create an HID device that does whatever you want, Teensy allowed you to do it. It also allowed you to create custom endpoints and push data in whatever manner you chose. So for a lot of people at least, including me, the Teensy was the starting point for HID attacks. Around that time, Rubber Ducky also became popular. Rubber Ducky is a product made by Hack5, which is basically a commercialized version of the Teensy. It does not use a Teensy, at least the new versions do not use it. But it's basically a plug and play. It's a lot easier to use. You don't have to muck around with C or CPP to get it to work. But there are certain limitations. But again, I think they have overcome that with the latest offering they have called the Bash Bunny. I think Mubix was giving it out yesterday. Yeah. So basically, Bash Bunny is it's a bit more powerful. It again, like what I'll mention later, it allows you to do composite devices, basically devices that are both HID and mass storage, or HID and Ethernet. So there are multiple attack fronts through which you can infiltrate and exfiltrate data. Again, if you want to go to the hobbyist route, something that has been coming up a lot in blogs recently is the use of Raspberry Pi Zero as an HID attack tool. Again, I mentioned this as a hobbyist, this one, because it's not easy to like hide a Raspberry Pi Zero, even though it's tiny inside a USB stick. So, why did I choose the USB Armory for this presentation? Mainly because it runs Linux. Initially, I thought that would make things easier, but the last few days, which I did not sleep properly, is probably contrary to that notion. But it was helpful because it ran Linux, which I'm familiar with. I was able to get a lot of things done. It's also the hardware and the software is open source. So whatever modifications that you want to make, you can make. Again, the form factor is it's just like a USB device. So you get a 3D printed case that is also available online. It looks just like any other USB device. Again, and whatever language that you're comfortable with, you can use it. For me, it's Python. So you can basically create your payloads in Python, or you can generate your payloads using Python, or whatever language that you're comfortable with. But the main reason I used it was because I had one handy. So, the thing about it is that right now I'm using a USB Armory with Windows 10 and Ubuntu virtual machine. I've tested it multiple times, but there might be interruptions in the demo. But then again, I hope I have not pissed off the demo gods today. So, the framework I'm going to use is something I wrote recently called the Offensive Armory. It's currently a very small tool. It basically allows you to, it basically automates a lot of the work that you need to do to make USB Armory an attack tool, or to use it as an HID attack device, and just allows you to specify what target that you want to attack and what type of payload you need. So it basically is a lot of startup scripts. So basically once you have activated your USB Armory with Offensive Armory, you can just plug it in and it should run the payload. I'll be posting this later today in my GitHub, so just keep a watch there. Okay, so let's move on to demos. So basically, before we get started, I just want to mention something, that USB Armory by default comes with Ethernet connection enabled on USB, or as an RNDIS gadget. So basically you can SSH to it if you set static IP addresses. But if you're playing around with the USB Armory, and if you're working with a USB subsystem, I would recommend you not to use that for while you're working with USB, because again, if you unload the G-Ether driver, excuse me, then you end up without an SSH connection. So here what I'm doing right now is basically I am connecting to the SSH ports on the USB Armory so that there's a connection even if the device crashes. So yeah, my first two demos are going to be pretty simple. It's basically an HID attack on Windows, just to pop a command shell and a PowerShell. So let's get started. So this is basically the serial console for this, and I'm going to run Offensive Armory. Lights. Thank you. So I'm going to run Offensive Armory, and it should tell me the various options. So now I'm going to run HID against Windows, and hang on. Okay, so it should generate a script. All right. Now, oh, sorry. Oh. Can you see it now? No? No. Sorry. Okay. Yeah, so how this works is basically it has a script called hid.sh written by Colin Mueller, which basically sets up all the endpoints and the USB information that is necessary for the USB Armory to work as a HID device. Then it uses string to HID to basically open up the run prompt using Windows R, and then it just types command. It's pretty simple. So So just to simulate me removing it and off, I'm just going to reboot. And if everything works out, yep. And yeah, so so it doesn't necessarily need to stop here. You can run whatever payload you want. It just continues after this. So again, my main repository actually has a few more advanced payloads, but yeah, this is the most basic one. You can just run commands. Instead of command prompt, you can run net use or any of the other inbuilt Windows commands. But this is basically how you would do it. You can even run PowerShell. So, and now if you reboot, it should come up with a PowerShell window. That's it for that. And again, I plan to add support for Nishang or any of the other PowerShell attack framework. So basically, you can import modules from that. But yes, it's not implemented yet. The next one is it's a composite device. Basically, the USB Armory is going to simulate Ethernet plus HID device, and it will be running a DHCP server on the USB Armory. So basically, when you the idea is when you connect it to a device, it would automatically assign an IP to the device, and then you can use the HID interface to input the commands and exfiltrate data using the network interface. So something that's been missing in a lot of HID attacks is a way to exfiltrate data. So if the device has internet connection, you could just wget or curl it out. But if it doesn't, then it becomes a bit more complex. So basically, right now we will be creating a composite device and using it to attack Linux. This is the one that usually gives me problems because right now it's passing through Windows 10, VirtualBox, and there are a lot of other components that could go wrong. Okay. Let's restart the USB Armory as a multi-device. So it should generate a script that would do most of the work. And now if we reboot, this is where it gets dicey. Ah, okay. So basically, after setting up a network on the USB interface, the next step for the USB Armory is to spawn a command shell. So for this case, just the script uses the normal shortkeys, that is Control-Alt-T. It generates that and then just inputs the code. There are again advanced methods available, like trying to communicate using caps lock. So previously, before composite devices were considered, another way for the host, which in this case is the laptop running Ubuntu, to communicate with the device is via caps lock or scroll lock or number lock. So the information that what is being sent is actually available to all the HID devices that are connected. Looks like the payload ran, but let me just confirm whether it got the data or not. But yeah, as you can see, it's basically running netcat, and it pipes the etc password file. Okay. No. Looks like the device got a different IP. So earlier there was an issue with, this was an issue with the DHCP server running on the USB Armory. I'm still trying to find a way around it so that you can you don't need to manually adjust the IP addresses, but it's still a work in progress. But yes, this should work. Yep, and this way you'd be able to extract data out of the device that you're targeting. Obviously, this is not the only way. Another multi-device that you could use is HID plus mass storage. So basically, it would be simpler than an Ethernet, because the only thing you would need to do is basically figure out where it is mounted to. In Windows, you could check the different drives. In case of Linux, you could just go from /mount stb to stc and figure out where it is. But in that case, it's as simple as creating a disk image and mounting it inside the USB Armory. So another thing to keep in mind is when you work with the USB Armory, just a minute. Yeah. You can also do a lot more advanced attacks. So another attack that was demonstrated recently, but that was using a Raspberry Pi, is to use responder.py, which is basically acts as a rogue SMB server. In that way, you can even connect to a device that is locked. So all the attacks that I've shown you right now will not work if the device is locked, because it's an HID device. It involves a certain amount of social engineering. The responder.py will work with a locked device. It basically simulates an SMB server, a rogue SMB server, and you can even get credentials from older Windows systems. Another thing that you can do is basically input a port scanner via the HID interface. It could be a PowerShell command, or it could be a binary that you wget in Linux. Another form of attack is to use a PIR sensor. So basically, it would connect to the GPIO pins of the USB Armory And so the main issue with HID attacks is to make sure the user is not there. Now the rubber ducky does this by basically sending commands fast, which is one way to do it. But another way to do it would be to sense sense if the person is in the same room using a PIR sensor. That is where the USB Armory's GPIO pins would be really useful. Again, I face a lot of issues getting this to work, mainly because I realized pretty late that the latest version of the USB Armory image that is being posted on the Inverse Path website is not compatible with HID devices. So if you need to work on this, you can either compile the image yourself. So kernel 4.4 works. The current kernel is, I think, 4.6 for the USB Armory. But if you use the 4.4 kernel, most of the devices should work. I have a compressed image, which I'll also be putting up on GitHub. But if you need it faster, you can ask me. I'll just share it with you. Another issue I faced was DHCP leases not working properly for composite devices. Again, this is one of the issues that we just saw. Basically, not all devices work the same. So if you're attacking Windows or Linux, you will have to slightly tailor your payloads so that the targets are affected. So on the same vein, I tried to get the network device, the composite USB plus the network plus HID device working with Windows, and I could only make it work with the Windows 7. So right now the product ID for the, you can see it, hang on. So basically the product ID and manufacturer ID that's being used for the composite device is the same that is there for an IBM network device. So this is done so that Windows 7 would automatically recognize and install the drivers. It doesn't work that way in Windows 10. So again, if you're working with Windows 10 and USB Armory, but then again, it's true for most embedded devices that you work with if you're using Windows 10. You will face a few issues getting this to work, but straight HID, straight network, or just straight mass storage should work. Composite devices have a few issues on Windows 10. Other than that, make sure you use VMware. Again, I have had much better results just working with VMware Workstation rather than VirtualBox, mainly because, again, VirtualBox USB subsystem creates a lot of headaches sometimes. Other than that, yeah, I already mentioned about the Windows 10. So, credits where credits are due. Antria Bersani and Inverse Path for the USB Armory. Again, it's a very good development board that you can work on. It's Linux, so it's very easy to use. Also, the documentation is kind of sparse, which is the only issue most people have. But I would recommend you go on the Google groups where Andrea and other members of Inverse Path actively respond to comments. Or you can even ask Andrea directly on Twitter. He would respond for most of your queries. Colin Mulliner for the HID scripts that I used. And a lot of kernel compilation examples given out by, I don't know how to spell his name, but yeah, CKUETHE. I think that's his handle. But yes, that's about it for this. So questions? Yes.